Unit 6, Parametric Equations in Polar Coordinates. Parametric equations involve a third variable called a parameter in addition to x and y. Usually this parameter is time and represented by t. We will define x as f of t and y as g of t, both functions of t. This is very helpful when tracing a curve and provides us additional information about the curve. For example, at a certain time t, we can find the position of a particle xy on a curve. We can also tell where the particle starts, ends, and the direction it's traveling. One important thing to remember is that the parametric equations representing a curve are not unique. This means there can be many different functions f and t and g of t that represent the same curve. Also, the domain is very important. Two curves may have the same functions f and g, but different start and end points, and different directions or different speeds. Coordinate systems define a point in space. So polar coordinates are different from Cartesian or rectangular coordinates since they use the angle from the positive x-axis and the distance from the origin to define a point, r theta. Think of a satellite in space and its distance from the center of the Earth, r. The gravitational force of the satellite depends on r. Polar coordinates are also used in navigation. We will also see a point represented in polar coordinates is not unique. So it has many different names, in fact infinitely many different names for one point in polar coordinates.